Hello everyone, we are the Arlington or the Portable 4-Channel Data Logging Oscilloscope team. We have Bishoy and Aziz on the hardware side, along with Huang and myself Taha on the software side. Now, the purpose of this project is to develop the design and implementation of a fully portable and touchscreen-based 4-channel oscilloscope to be used in the analysis of electrical signals that can additionally save voltage versus time data across all 4 channels onto an SD card to be later viewed on a computer. Furthermore, this device will include features to generate either a 0 to 5 volt PWM pulse train or an adjustable PWM pulse signal. Next up, we have Huang with the background and applicability.
Okay, so while several known companies today work on the development of oscilloscope for laboratories and other purposes, like Regal, Agilent, Keysight, etc., they continue to remain as primarily stationary devices, with only a handful of current companies working toward implementing portable designs with limited capabilities. The most readily available portable oscilloscope in the market lack two major elements of what this project can provide: the data logging of the signals from the channels, along with the being fully interactive through a touchscreen LCD for the users. Applications for this portable oscilloscope design range from being friendly and easy to use for both hobbyists and engineers, alongside being fit for commercial or military usage in the tracking and analysis of signals throughout many analog and digital electrical designs. In selection for processing and displaying the data of the waveforms coming into each channel, the TNC 4.0 was chosen as a microcontroller, alongside with the Nexeon 7-inch Intelligent Series capacitive touchscreen LCD. Now, Bishal is going to talk about the general design overview.
Looking at the general design overview as seen in the block diagram, with the hardware design details in mind, with this design, the maximum voltage range of signals for each individual input channel is between -10 to +10 volts with a bandwidth of 100 kHz. After passing through 1x BNC probes, the input voltage is initially scaled down with current limiting resistors in series, along with clamping diodes to help protect against any overvoltages coming into the device. Each channel then goes through a programmable gain amplifier, or a PGA, that can be used to amplify smaller signal ranges to the full range of the ADC, which lead to more precision-based readings. Signals are then properly scaled to a voltage divider with a specified 2.5 voltage reference offset in order to scale all signals between 0 and 3.3 volts for the full range of the ADC. A TNC 4.0 microcontroller will then be connected through UART to a 7-inch Nexeon Intelligent Series capacitive touchscreen LCD, which helps to display and operate the oscilloscope through a user-friendly graphic user interface. A micro SD card module will be connected as well through SPI to the TNC to allow for the ADC channel readings to be logged as a voltage across time reference into a simple CSV file extension where the user can later access and view and analyze the data. Generation of signal pulses using PWM capabilities of the TNC will be user selected from the LCD and then properly boosted through a rail-to-rail operational amplifier from 3.3 to 5 volts for the output voltage. And next, I'll give it up to Aziz for the PCB design.
As far as the printed circuit board and assembly are concerned, here's a complete PCB design ready to be milled. The dimensions are 6 by 4.3 inches. 2 layers are used for traces and polygons. Top layer is used for placing components at ground planes. The bottom layer is used for 5-volt plane to power the entire system. Analog and digital grounds are separated through a 0-ohm resistor to minimize possible noise resulted from digital components. The copper traces width is made 16 mm to offer a less resistive path for transmitting signals between components. The user will have access to 3 components on the right side of the board: micro USB to charge the battery through a power module, the SD card slot, and the rocker switch as on-off switch. There are 5 BNC connectors at the top, 4 as input and 1 as PWM output. The clearance distance between BNC is 0.58 inch. The board has 4 mounting holes with a diameter of 0.125 inch for 4 to 40 panhead Phillips screws. The board should fit behind the LCD and will have enough room for LiPo battery to put in one case. Now I'll pass it to Taha to conclude this presentation.
With continuing progress, there remains a couple of tasks until the full completion of the project. Namely, the aforementioned PCB design is currently being sent off for fabrication, while the software is concurrently being worked on to ensure as many design requirements are being met. On the software front, a total of 3 LCD GUI menu or page designs have been created to implement functionality such as the channel on-off displays, the vertical or / horizontal transformations of each channel signals, and other miscellaneous features not typically associated with oscilloscopes of this caliber. At this point in time, the first of these menu / pages, the channel on-off display, is fully functional and working. Upon the fabrication and population of the PCB board, the software and hardware teams will converge to conduct the appropriate testing, complete the integration of the project. Finally, we'd like to take this opportunity to thank the wonderful sponsor from Naval Research Labs, Dr. Brett Heumann, and the UTAEE department, Dr. David Wetz, along with our senior design course instructor for the semester, Dr. Kondrasky. Thank you.